In this video, you will learn about the fundamental principle of counting. Now, to illustrate this principle, let's say that you are looking to buy a shirt. There are 4 different shirts you like, and each one comes in 3 colors: red, green, and blue. And the question is, how many possibilities of shirts do you have to purchase? While looking at the first shirt comes in 3 colors: red, green, or blue. So here for shirt 1, we have red, green, or blue. For the second shirt, we have the same number of options. It could be red, green, or blue. Third shirt, same thing. Fourth shirt, same thing. So what we have is going to be 3 times 4, or 12 possibilities of shirts. So we have 12 options to choose from. Now this illustrates the fundamental principle of counting, which says that if one selection can be made in m ways, and for each of these a second selection can be made in n ways, then the number of ways the 2 selections can be made is in m times n ways. And that's what we saw in the last example. Here is maybe kind of ambiguous with m and n without seeing actual numbers or an example, but just think through the last example. We had one selection of shirts could be made in 4 different ways, right? We had 4 different shirts to choose from. And for each of these shirts, a second selection can be made in 3 ways because we had 3 types of shirts, or 3 colors of shirts. So for each shirt, so for each 4 shirts we have, each of those can be chosen in 3 different colors. So we have 4 times 3, which was our 12. So in the last example, instead of m and n, we had 4 and 3. Now this principle is useful when it comes to counting things quickly. So in the last example, we listed out each of the shirts and how many colors we had, and we could count each one separately to get 12 options total. Now when you have a larger number of things to choose from and more maybe criteria that we can include, then the numbers are going to get too big where we can't count every single option. So that is where this principle comes into play. So next example, we are asked how many odd 2-digit positive integers greater than 30 are there. So yes, we could count every 2-digit number that's odd, that's bigger than 30. We get things like maybe 31, 33, 35, 37, 39, etc., all the way up to 99, which is the last odd 2-digit number. But that's going to take a long time. So we want to use our fundamental principle of counting to speed up the process, and we're going to determine the number of options we have for each of the digits and then multiply those together. So we know with a 2-digit number, 2 digits means we're going to have a tens place and a ones place, right? So like for example, numbers we could have would be 31, 33, 35, 37, 39, etc. We have a tens place and a ones place. Now for the tens place, we need to determine how many options do we have. Well, the tens place could be 30 something, we could have 40 something, could have 50 something, 60, 70, 80, or 90 something. All right, each of those would fit the criteria. It'd be 2-digit, greater than 30, and we stop at 9 because once we get into like after 99, after 90, we're going to get into 100s, which is going to be 3 digits, but it needs to be 2-digit. So the tens place could be a 3, 4, 5, 6, 7, 8, or 9, which is 7 options. Now for the ones place, the last digit we know needs to make the entire number odd. All right, it needs to be an odd number, right? Be like 31, 33, 35, 37, 39, etc. The only options we have for this last digit for the ones place would be any odd digit. Well, we have 5 options to choose from, right? It could be 1, 3, 5, 7, or 9. So we have 5 options for the ones place that would make it odd. And so we take 7 times 5, and we get 35 as our answer. So what we've determined is that there are 35 numbers that are bigger than 30, that are 2-digit, and that are odd. One more example like that. Here we have how many odd 3-digit positive integers can be written using the digits 1, 4, 5, and 6. So this one, same idea. We have 3 digits. So we have hundreds place, tens place, and ones place. Now for each of these, we are limited to the numbers 1, 4, 5, and 6. So that's 4 options at most that we have for the hundreds, tens, and ones place. Now the question is, are there any other limitations? Well, it says it needs to be odd. So odd would affect this ones place right here. Alright, so this ones place needs to be odd as well. So what odd digits do we have to choose from? Well, we have 1 and 5, and that's it. So there are only 2 options for the ones place. Alright, so we've taken care of the odd criteria. Next, it's got to be 3-digit, and it doesn't say anything about being greater than anything or less than anything. So there's really no other criteria other than the fact we have to use 1, 4, 5, and 6. So we have 4 options, 1, 4, 5, and 6 for the hundreds place, and 4 options for the tens place, and then 2 for the ones place. So multiply those together. 4 times 4 is 16. 16 times 2 would give me 32 options.